Welcome to One Chemistry. Always try to do your best. Now, let us see about 100 conversion in organic chemistry. We are seeing it as episode. This is the episode number 132. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal is cyclopentane which attached through single bond. It has 2 OH on the connected carbon. You are using the acid. They ask you to find the product. The product has spiral kind of ketone or alkene formation on 2 cyclopentane, or a S-cis alkene formation, or a S-trans alkene formation, or alkene formation on any one of the ring. So there are the 4 possibilities. So from the reactant to product you might realize the fate of OH as well as the special reaction involved here. The answer is A. Let us see how. The starting metal is phenol. It is a diol there. You are using the acid. It is called phenol-phenolone rearrangement. In the reaction, OH is protonated. It formed as H2O as a cation. Then H2O removal is there. You have cation formation. Now the cation has to be quenched. How the cation will be quenched? The methylene group migrates. So methylene group migrates, the cation formed near the OH group. So quenching of cation is by formation of ketone there. So alcohol become ketone for cation quenching. So if you redraw nicely, you have the answer A, which is pyro kind of compound. Here you have to learn 2 important things. One is phenol-phenolone rearrangement. If you have diol and acid as the catalyst, you might think of phenol-phenolone rearrangement. Second thing is methylene group migration. Here methylene group migrates to quench the cation because it is the only pathway to quench the cation by ketone formation. Then the question number 2. The starting metal is benzene attached with side chain which has alcohol and acid. You are using the base potassium carbonate and benzyl bromide. They ask you to find the product where the benzyl bromide attacked there, whether it is an acid or an OH, and acid and OH are a substitution in the methylene carbon. So there are the 4 possibilities. So from the question to product you might realize where the benzyl group attack is the real question here. The answer is A. Let us see how. The starting metal you have 2 functional groups. One is acid and alcohol. If you compare the acidity, acid is a good H plus donor. Similarly, you are using potassium carbonate. It's a weak base. It cannot take all the protons easily. It only attracts the proton which is easily donate. So potassium carbonate only abstract the proton from acid. So anion forms, anion attack benzyl bromide. So direct OC bond formation. So benzyl attached as ester, which is answer A. Here let us discuss the other possibilities. So potassium carbonate is a weak base, only take from strong acid. So COH form an anion. Similarly, potassium carbonate is a weak base, only take from strong acid. So take out from COH as form anion. Second point is it is a weak base, cannot abstract the proton from the alpha carbon. So the alpha hydrogen cannot be removed. So answer D, which is substitution, is not possible. Similarly, the weak base cannot take out from OH. So answer B as well as C is not possible. Here answering question as well as excluding the not correct answer is important here. Here you have to learn 2 important things. Whenever you think of reactivity between acid and alcohol, you think of acidity. Second thing is not always selectivity of reactant is important. Here selectivity defined by the base. Base dictate the whole reaction. Then the question number 3. The starting metal is hydroxylamine. It has both sides benzene. It has one side benzene, another side anisole attached in the para form. Here you are using HCl as the catalyst. They ask you to find the product. The products are amide formation. The amide formation, nitrogen formed near the anisole or to the benzene, or amide formation with N double attachment, which is N benzyl and N anisole attachment. So from the reactant to product you might realize that naming reaction is involved as well as the migrating ability of attached groups are important. The answer is B. Let us see how. The starting metal you have hydroxylamine, you are using the acid. Acid protonated the alcohol and it removed as the water. So H2O plus remove, cation formed at nitrogen. So cation forms, it has to be quenched. So how it can be quenched? The anti-group, which is phenyl, migrates. The migrating ability decided by the anti-group. So anti-group, a trans group is phenyl, there it migrates. So you have the cation formation at the carbon there. The cation has to be quenched. So OH minus, the removed water attacks. So OH minus attacks, you have OH formation. So there is a heat-vinyl tautomerism, you have amide formation. So nitrogen formed near the phenyl group. So the answer is clearly B there. Here you have to learn two important things. One is Beckmann rearrangement. Beckmann rearrangement form amine to amide. Second thing is the migrating ability. In Beckmann rearrangement always anti-group migrates. Then the question number 4. The starting metal is chiral compound. One side attached with methyl, phenyl and hydrogen. Other side attached with methyl, hydrogen and amine. Here the methyl iodide and silver oxide and water and the heat is provided. They ask you to find the product. The products are alkene. Whether the alkene is cis or trans or you can say E or Z or alkene formation in the side chain CH2. Whether the configuration changes occur, pH go above or below. So there are the 4 possibilities. So from the reactant to product you might realize NME2 eliminated regioselectively and stereochemistry of elimination is important here. The answer is B. Let us see how. The starting metal you are having amine, you are using methyl iodide. Methyl iodide methylate the nitrogen, it form quaternary ammonium salt. The ammonium provide counter ion which is OH minus, so the cation is there. It has to be quenched. The quenching pathway will be elimination. So we redraw with conformation here. So NME and hydrogen on the plane, phenyl and hydrogen above the plane, methyl behind the plane. So we redraw in the conformation form. Here amine and hydrogen should be anti to each other. So we rotate the bond. So we rotate the amine top to bottom. Hence hydrogen and methyl positions are changed. So the elimination is possible because hydrogen and N-methyl is anti. The elimination occurs. So you have alkene formation. If you look at nicely, it's a Z configuration where high priority pH and CH3 are on same side. So if you redraw nicely, you have the answer B. Here you have to learn two important things. One is NEME3 plus removal. It is a Hoffman elimination. It need anti-periplanar position for the removal. So we have to rotate the molecule. Second thing is you have to imagine the molecule in the 3D. Here we reimagining structures through the Sahar's form. Then the question number 5. The starting metal is in question. The product is epoxide and it has tertiary butyl group. Here 4 reactants are given. One is amine and alcohol anti to each other, syn to each other, anti to each other in axial and equatorial. Both can be exchanged. So there are the 4 possibilities. So from the reactant possibilities and product you might understand ring closure definitely occur and stereochemistry of ring closure is important here. The answer is A. Let us see how. The starting metal you are having alcohol and amine, you are using nitrous acid. Nitrous acid converts NH2 into N2 plus. It's a kind of diacetization. N2 plus is there, OH is there. So what really happens is OH assists the N2 to leave, it form epoxide. Since OH is above, epoxide also above the plane. So the product is clearly A. One might think of answer can be B, but you have tertiary butyl group. Tertiary butyl group is a locking group, it don't allow the ring flip, so that trans won't help here. So for the elimination, the OH and NH2 should be axial as well as anti to each other. Here you have to learn two important things. One is locking group. Whenever you have tertiary butyl group, it's called locking group, it don't allow the structure to flip. Second thing is epoxide formation. For the epoxide formation, both groups should be anti. Here N2 plus OH is anti as well as axial. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.